All right, we're going to do the last section of derivatives right here. Well, there's one section we're just skipping, but this is the last section of derivatives. It's called L'Hopital's rule. Do not call it Hospital's rule. It's L'Hopital. It's fun to say. L'Hopital. Say it. Say L'Hopital. We're going to L'Hopital it. L'Hopital. All right, we're going to L'Hopital some limits here. So let's take a look at what it means. When we were doing limits earlier in the year, we would get what we call the indeterminate form when we tried direct substitution. And the one that we mostly looked at was 0 divided by 0. We said, well, there's a hole there, and we have to continue on and simplify with some algebra, and then we can redo direct substitution and find the limit. Well, we're going to use this rule. It's called L'Hopital's rule. And that rule is going to make it much easier so we don't have to do the algebraic method to find the limit when it's in indeterminate form. So let's look at one that we did earlier in the start of the class. So, note that. Sorry, let's put it up here. So if we wanted to evaluate this limit with direct substitution, we would end up getting 0 over 0. So when we do the factoring, let's see, we'll do it over here. Oh, I wanted to do that. Sorry. Okay, so when we do the direct substitution, we get 0 over 0. So then when we factor, we can do some algebra to solve, right? So it factors into this. We can simplify to get our agreeable function, which is now 2x plus 5, or x plus 2. And we plug 3 into that, and we can get our answer. So we get 11 over 5. So that's the long way to do it. And if you remember calculating some of these limits with algebra, this one that we just did, I would consider it an easy one. This was like the easiest version. We know there were some crazier ones with square roots and simplifying fractions inside of fractions. So we kind of want to avoid all this algebra whenever we can, and that's where L'Hopital comes into play. You got to hold that. You got to hold one of the L's when you say it. I like holding that first one. You got to go L'Hopital if you hold it. It's really fun. If you haven't done it yet, I suggest you take it for a spin. It's a good time. Got to hold that first L. So back to the story. Let's look at how we do this with L'Hopital's rule. First, we'll tell you what the rule is. So if the limit as x approaches c of f of x equals 0 and the limit as x approaches c of g of x equals 0. This is for a function, by the way. If we're trying to find the limit as x approaches c of f of x over g of x. And if the limit of the top, excuse me, is 0 and the limit of the bottom is 0, in other words, you get 0 over 0. And if you take the derivative of the top and the bottom, and we're not talking about doing quotient rule. This is why L'Hopital's rule is really easy. When I say take the derivative of the top and the bottom, it means take the derivatives independently. Just the top, that's the top part, take the derivative, and then take the derivative of the bottom part, and you get just the bottom part. If you can take the limit of that and actually get a real number, then that's the answer. That would also be the answer to your limit. So we'll say if that's the situation, or if when you do the limit of the top, you get positive or negative infinity, and the limit of the bottom, you get positive or negative infinity. And again, when you take the derivative of those, you don't get that anymore. You actually get a real number. Oops, that's a G. So this is just saying, look, all these indeterminate forms, 0 over 0 or any combination of infinities, if you can take the derivative of the top and the bottom and get an answer, then that answer is the limit of the original guy. Sounds all complicated when I say the rule. Here's what we're going to do. We do direct substitution. we know that we get 0 over 0. So now I know, okay, it's an indeterminate form. So now what I can do, instead of doing all this algebra, a faster way sometimes is to take the derivative of the top, take the derivative of the bottom, and now try taking the limit of that by direct substitution. So if I plug a 3 into that now, I get 4 times 3 minus 1 over 2 times 3 minus 1 equals 11 over 5. That was the answer we got the other way. So you can see L'Hopital's rule is much quicker. And why did I wait to show this to you? This is the last thing we do in derivatives, because you were having to take a lot of derivatives all over the place. And once I show students L'Hopital's rule, they want to use it all the time. So in other words, if I just said, here's a function, like let's say we had a question on a midterm or something like that, or any other kind of question where you were just asked to take the derivative of this function, this is not the derivative. You have to do quotient rule to take the derivative of this function. But once you see L'Hopital's rule, it's used only when finding limits. You can take the derivative, if you get an indeterminate form, you could take the derivative of the top by itself and then the derivative of the bottom by itself. Be clear that this function is not the derivative of that function. It's just a different rule that we're applying to limits only. And once students see this rule applied in limits, they start to want to do that all the time for the derivative instead of doing quotient rule on a different type of problem where you're just asked to do a derivative. So this is why I'm showing it to you last, because I didn't want you using this rule all the time. Okay, it's a weird thing, but it's because it's so easy to take the derivative of the top and the derivative of the bottom, students start doing that all the time. Okay, this is not how you take the derivative of this function. It's a separate rule called L'Hopital's rule. So let's look at some other limits that we had to use. When we were finding like the derivative of sine and proving it, we were using the limit definition, and one of the limits we came across, these famous limits, we called them, if you recall. I was saying those are famous limits that show up. I just told you to memorize this fact. After I showed you how to do it like on a graph, we kind of analyzed the graph to come up with the limit. But now that we have L'Hopital's rule, we can do a more vigorous demonstration or proof of how this limit works. So first of all, I try direct substitution, and I get sine of 0 is 0 over x is 0. So that's an indeterminate form. So now I can apply L'Hopital's rule, take the derivative of the top, and then take the derivative of the bottom, retry direct substitution. Cosine of 0 is 1, it's over 1. So I get 1. And that's what we said that limit is. So again, L'Hopital's rule just made this a lot easier. Now let's try it with this other famous limit. So if I do try direct substitution, I get 1 minus cosine of 0 is 1 over 0. I get 0 over 0. It's indeterminate. So let's L'Hopital it. I'm telling you, if you haven't tried it yet, say it. We're going to L'Hopital it. Hold that first L. Just make sure, look around. You're probably in your house. Make sure nobody's around. If no one's around, hold that L for a long time. Let's do the derivative here. The derivative of cosine is negative sine. So we already had a negative in front there, so it becomes sine. Derivative of x is 1. Now I retry direct substitution. So if I plug 0 in, the sine of 0 is 0 over 1, which is 0, which we found out we already knew that limit was 0 from before. But now we're applying a new rule, L'Hopital's rule. So in the past, I used to teach L'Hopital's rule. As soon as we learned like derivatives, I would go back and teach L'Hopital's rule, even for some easier stuff. But I didn't like that people were confusing it with the derivative. Another reason we wait is you need to know how to take all different kinds of derivatives of all different kinds of functions. You have to know how to take the derivative of cosine and all that kind of stuff. All right, so now we're going to do some practice with L'Hopital's rule. So I try direct substitution first. And I know it's going to be indeterminate because they're telling me to use L'Hopital's rule. But cosine of pi over 2 is 0. And so it's negative. It doesn't matter, though, because it's 0. And then pi over 2, so I get 0 over 0. So I can use L'Hopital's rule. So as x approaches pi over 2, the derivative cosine is negative sine, so that derivative becomes sine. On the bottom, I get 1 minus 0, so it's just 1. So now I can retry my direct substitution. I plug in pi over 2. Sine of pi over 2 is 1, so I'm getting 1 over 1, which is 1. So that's the answer to our original limit. If I try direct substitution here, I get 0 minus 0 on top. I get 0 minus 0 on the bottom. So now we're going to do L'Hopital's. I'm going to take the derivative of the top. I'm going to take the derivative of the bottom. Whoops. Don't forget your chain rule. I'm going to retry direct substitution. So I get 7 minus 1 over 0 plus 3 times 1, because cosine 3x. Cosine of 0 is 1, and then times 3. So I've got 6 over 3. So that limit is 2. And it just goes on and on and on, and we can still keep using L'Hopital's rule. So sine of 0, that's going to be 0, that's going to be 0 L'Hopital, because it's indeterminate form. So the derivative of sine times cosine is going to be a product rule on top. So the derivative of sine is cosine. Recopy the cosine. Plus, recopy the sine. The derivative of cosine is negative sine. All over. The derivative of x is 1. The derivative of sine is cosine. Don't forget chain rule times 2. Let me simplify this a little bit. Cosine squared of x minus sine squared of x. Whoops. All over 1 plus 2 cosine of 2x. Now I can retry direct substitution. And I get cosine squared of 0 minus sine squared of 0 over 1 plus 2 cosine of 2 times 0. So that's going to be cosine of 0 is 1. Sine of 0 is 0. Cosine of 0 is 1. So I'm getting 1/3. Okay, let's try this one. If I try direct substitution, cosine of 0 is 1. Cosine of 0 is 1. Cosine of 0 is 1. So I get 0 over 0. So I'm going to L'Hopital this. So the derivative of cosine is negative sine. Cosine is negative sine. 2 comes along for the ride. Oh, my pen just died. Give me a second here. Charging. I should pause the video, but I'm not going to. Just take this second to just zone out. Maybe practice saying L'Hopital a couple times. All right, let's see if I charged enough. Yep. So where was I? Derivative 2. So the 2 comes on for the ride. The negative becomes a positive. Cosine is sine. Recopy the inside times 2. Derivative of the bottom is sine. Oh, no way, did my computer just die?